This is the Defend on the Way Up episode for the whole playlist. We've made the model wrong 3 ways. Now we make it hard to fool. There's a catalog of model-level defenses. Each genuinely helps, each costs you something, and one of them only looks like a defense. We'll place them as layered gates and name the trade-off every single time. Model-level defenses for LLM-04. Harden the model, price the trade-off. The defense catalog, every gate green, every cost honest. S1 Train and S4 Inference light up in clay. This episode lives at both ends. Everywhere else dims to 25%. A learned flaw has no hot fix. Here's the single red dashed perturbation dot, the through line every defense in this episode has to stop. The model behind it is bare. Watch each gate either turn it green or fail to. Defense 1. Adversarial training. Train on perturbed examples so the decision boundary thickens and sits farther from real inputs. The red dot no longer reaches the cluster. The strongest empirical defense and the most expensive. Defense 2. Randomized smoothing. Scatter noise around the input, vote across noisy samples, and earn a certified radius the input can't be pushed out of. Paid for an inference cost. Many queries per decision. Defense 3. Certified defenses. A green band around the boundary with a provable guarantee. No input with an epsilon flips the answer. You move from we tried hard to math. The catch, the bound is tight and hard to scale. Defense 4. Defensive distillation. Model A's softened output probabilities train a second, smoother Model B. Gradients flatten, the attacker's bar goes up. But it's empirical, not a guarantee. Don't oversell it. Defense 5. Model ensembles. Several diverse models vote on one input. The red dot fools one. The majority still votes correctly. Robustness for the price of n times the compute. Detection layer. Statistical detection as a pre-filter. It flags inputs and training slices that look off distribution, callbacks to outlier detection and scanning from earlier episodes. Catches poison and probing at the cost of tuning false positives. The trap. Gradient obfuscation looks green at first, then stamp the red skull, often broken. Watch the attacker simply route around the hidden gradient and reach the model anyway. It's false security. Do not stack your story on it. The honest ceiling a seesaw. Robustness on one side, clean accuracy and compute on the other. Push one up, the other tilts down. There is no free robustness. That's the trade nobody puts on the box. The payoff. Run the lone red dot at the stack. Adversarial training, smoothing, certified detection, ensembles. It hits the layered green wall and stops. Red turns green check. The model behind, untouched. Not one wall. Defense in depth, each layer priced honestly. Harden the model, price the trade. That closes the integrity attacks. Next, episode 3. They stop corrupting the model and start stealing its secrets. Break it on the board, not in prod. 5 real defenses and 1 trap. Adversarial training is the strongest empirically and the most expensive. Randomized smoothing and certified defenses move you from we tried hard to provable within a bound. Defensive distillation and ensembles raise the cost of an attack. And gradient obfuscation only looks safe. It hides the gradient, not the weakness, and it's often broken. The honest rule: every layer trades against clean accuracy or compute, so stack them and measure.